All right, thank you for coming to my session, everybody. This is a session on M for data access and analysis services. So quite an obscure topic maybe, but still exciting. I guess everybody here is interested in analysis services, yes?
Yay!
Yay, hooray, good. I think this is the kind of topic that you wouldn't come to unless you were really interested in analysis services. First of all, let me introduce myself. My name's Chris. For years and years and years, I was only ever interested in analysis services. I've been working with analysis services for 18 years now, I think. Then, a couple of years ago, I got interested in something new, which was Power Query. And I liked that so much that I thought I'd write a book on it. And now I am the luckiest man alive because my two favorite technologies have gotten married. And they've had a baby. And I have got Power Query integration with analysis services. So that's what I'm here to tell you about today. We will look at what the new features are in Analysis Services 2017 and also Analysis Services, Azure Analysis Services Tabular. We can see how the UI and the integration works. That's all pretty straightforward. We will talk about what M is, because you need to have a little bit of basic understanding of the M language before you understand the next bit, which is all of the cool things that this is going to mean for analysis services. And there are going to be lots and lots of really useful things that we can do with this. We will finish off by talking about the things that you should not be doing with this new technology as well. Because this is one of those technologies where there is a great potential for doing cool stuff and a great potential for doing stuff that you should not be doing. So we will have a look at that as well. First of all, what's the change? In Analysis Services Tabular 2017, which will be released sometime later this year, and also Azure Analysis Services, which has already released, there is going to be a new way of loading data. So in the past, you said, let's create a data source. You connected to something like SQL Server for a long list of data sources, and you imported tables from those data sources. That part of Analysis Services Tabular is the part that has been replaced. And what we've got instead is the Power Query user interface for connecting to data sources. And we've also got underneath that the M language driving all of this. So, as a developer, when you're connecting to one of these, connecting to a data source, you are basically going to be using something similar to the Power Query user interface. This is also what's now called Get and Transform in Excel 2016. This is what is used in the query editor in Power BI Desktop. Power Query as a brand name has kind of disappeared from view within Microsoft. Power Query was the name of the Excel add-in that then subsequently got integrated into Excel 2016 as Get and Transform. But now we've got this technology that connects to data. It's used in Excel and called Get and Transform. It's the query editor in Power BI. It's the data connection experience in Analysis Services. It's the same thing, but it doesn't really have a name. And in fact, the Microsoft internal team name is Power Query, so I'm going to still call it Power Query. Anyway, it's the new data access experience. And, like I said, it's basically complete on the engine side. It wouldn't be in Analysis Services Azure if it wasn't. The bad news is that the tools are not quite finished yet, even though supposedly SSDT has been released as well, and we will see some more of that. But it is mostly integrated into SSDT. There are some changes to the user interface because apparently Visual Studio doesn't support ribbons. So we don't get the same ribbon-based interface that we get in Excel and Power BI, unfortunately. They've had to put everything on drop-down menus, which I don't think looks so good. But, it's understandable. All right, how does this work? Well, let's do a demo. Here on this virtual machine, I've got Visual Studio. I'm going to create a new project. I'm going to create a new Analysis Services Tabular project. Let's call this SQLDay. Click OK. Then here I'm going to choose an integrated workspace. Now here it's important that I choose to use the 1400 compatibility level for this project. The new data loading experience is only going to be available in the 1400 compatibility level. It still will be possible to use older compatibility levels with Analysis Services 2017, where you get the old data loading experience. And indeed, old style data sources will still be supported in Analysis Services 2017. They're just not going to be the ones that you build by default. So if you migrate, everything will still work in the way that it used to. So I'm going to create my new project here. I've got the new Tabular Model Explorer interface here, and I want to connect some data. Now, if I look on my desktop, I've got a CSV file here. Come on, there we go. So I've got a CSV file with some data in it. It's not very interesting. It's just some products and colors and stuff. So let's make that a little bit bigger. So you can see the data there. It's very, very straightforward. All right. I'm going to right-click here in the Tabular Model Explorer to say, let's import from a data source. Anybody that's used Power Query in Excel or Power BI will be familiar with this interface now. I'm going to connect to a CSV file. I'm going to point it at that CSV file that I just showed you. Now here, this is where something is slightly different from the experience in Power BI. I have to specify some credentials, but this is just a CSV file. I wouldn't have to do this in Power BI. Well, you have to remember that it's not going to be me that's connecting to the data. This is going to be Analysis Services that is connecting to the data, so I have to provide some credentials for Analysis Services to connect to the data. Let's just connect as me. Click Connect, and we're good. And the Query Editor screen opens. So again, this is similar to what we've got in Power BI Desktop and Power Query, but like I said, we don't have a ribbon-based interface allowed in Visual Studio. We've got menus and buttons. But as we can do with Power Query and other places, I can change the name of my query, and I can not only import my table as it is, I can do some filtering. So perhaps let's filter by color. So I've filtered some rows out. And then here perhaps let's do transform table group by. We'll group by color, and we'll get the count of rows and the sum of sales by color. Click OK, and we have a table of data. Click Import, and you'll see Power Analysis Services chugging away. It's imported 2 rows, and there's my data imported into my project, and everything after that is exactly as you would normally have with your regular Analysis Services Tabular project. A few things to point out. Let me import that table again. So if I go to import new tables, and we have a look at this, and we do some filtering, again, a few technical terms to point out. What I've got here in this left-hand pane is a query. A query is a job that connects to one or more data sources and does something to that data. And it will usually, but not always, usually return a table. Now, one query contains one or more steps. So when I applied the filter to this table to filter on color, a new step appeared here. I could edit that step by clicking on the gear icon and changing that. And when I did the group by, or just group by and get a count, you can see that a new step was created here. So a query consists of one or more steps. I can click on a step here in the query editor and see the data at that point on that step as it was. So I've got a nice visual way of seeing all of the changes that were made to my data. I can have multiple queries, and each query usually will return a table into the Analysis Services Tabular data model, but as we'll see, it doesn't have to. There are tons and tons of options up here for filtering data, for filtering rows, for removing columns, for renaming columns, for doing calculations, all kinds of things. A query here is actually turned in the background into a script. So this user interface is basically just generating code in the background, and the code that it generates is a language called M, which we'll see a bit more of in a moment. But if I want to view the M code, here is the M code. I'll teach you a little bit of M in just a moment, but I know that looks scary. It's a lot less scary than you might think. The last thing to say, a few things which will be kind of relevant for later on. We don't always have to load the output of a query into the Analysis Services data model. A query can use another query as a data source. So you can chain multiple queries together. You can combine data from multiple queries. You can do joins between multiple queries as well. So that's all we're going to need to know about the query editor. It's very straightforward, very, very easy to use. It was designed for Excel users and non-technical power users to use. So I'm sure everybody here will be able to work out how to use it very, very easily. Now let's talk about M. M is the language behind all this. M is the really, really exciting thing. So M is a functional language, and the whole point of M is that it is a language for transforming data. Now, there are three unique selling points about the M language. First of all, it is a language that was designed to be generated by a user interface. Now, a couple of months ago on the internet, I saw somebody who had posted a blog post saying, oh, let's compare R and M, and look, R is much, much better because you can do way more stuff. You can do more transformations, you can connect to more data sources, you can do all of this analytical stuff, blah, 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 which was all fair enough. The point about R is that it's a language that you write. One of the points about M is that it is a language really designed to be generated. You can write it if you want, but most of the time, even when you're technical like us, you will actually just be using the user interface to generate it. And it is perfectly possible to do the majority of your work in the user interface and then just go and make a couple of alterations in M and then flick back, and then the user interface will still work. So this is an easy thing to forget. It's probably not so important a point for Analysis Services users, but this is a language that's very closely tied to its user interface, to the code that generates it. If you think about all of those attempts at, for example, SQL generation, you know how badly that works. The fact that this works really well and the integration is very tight is a tribute to how much time they've spent working on this part of M. The second thing about M, or the second defining feature about M, is that it allows you to manipulate data from any data source in a totally consistent way. Whether that data is coming from a CSV file, whether it comes from a JSON document, whether it comes from a web service, whether it comes from a table in SQL Server, the bit of code that connects to that data source will be slightly different. But once you've got the data back, you can do and manipulate your data in exactly the same way with exactly the same code. The third thing, which is probably the most important point as far as we're concerned for analysis services, is query folding. So we've just seen connecting to a CSV file and making some changes. Now I've got the same table in SQL Server. So what I'm going to do here, let's cancel this. I'm going to create a new data source. And now let's connect to SQL Server. I don't need to connect to the database just yet. Again, I'm going to impersonate me. Click connect. And again, this is going to be very, very familiar for anybody that used Power BI. I'm going to connect to a database. And now let's import a table. Let's connect to my table here. It's the same data. You can see that if I do the same set of filters, let's get green and orange here, and then we do a group by, and let's add a sales column here. You can see that the UI behaves in exactly the same way regardless of whether I'm connecting to a SQL Server database or a CSV file after I've chosen the data source. If I was to show you the code and compare the code, apart from these two lines of code that connect to the data source, the other two lines of code for doing the filtering and the aggregation would be the same. But the important point here, and this is the important point with query folding, is that wherever possible, M does not do its transformation and filtering and other things that it does in its own engine. It does have its own engine for doing filtering and transformation, but if you imagine we were connecting to some gigantic SQL Server database and connecting to a table with 6 billion rows in, if you were applying some filters to that table and doing a group by, you would not want to download all of those 6 million rows onto your desktop or even to your analysis services server and then have the M engine try to do it there. That would be crazy. So the point about M, and this is probably the most important aspect of the engine that people always miss, is that wherever possible, it will push the transformation work that you define in your M code back to the data source. So this is what query folding is. So query folding is going to be absolutely vital for good query performance. Query folding can only take place for certain types of data source. Obviously, if you're connecting to a CSV file, there is no engine in the CSV file where you can push these transformations back to. There is no choice but for the M engine to do the filtering and the aggregation, the transformation in its own engine. But for data sources like relational databases, like SQL Server, when you define your query, effectively M is going to take that query and translate it back to SQL. If you're connecting to Oracle, it will hopefully generate some SQL that Oracle likes and tune for Oracle. If you're connecting to other data sources that support query folding like analysis services, it's going to be generating MDX. It also, for example, supports OData data sources for query folding. If you've come across OData, it's kind of like a Microsoft standard for web services that work with data. And when you're connecting to an OData data source with the M language, then you will find that query folding takes place, and it will generate queries expressed as calls to the web service to be able to do any filtering and aggregation. So query folding will only take place for some data sources. There are some things that you can do in M, even when you're connected to a data source that supports query folding, that the language either doesn't know how to translate back to SQL or probably never will be able to translate back to SQL. So what you'll find is that for more complex queries, some of what you do can be translated back to the data source, query folded, but other things may still take place in the engine. It depends on what you're doing. But the heavy lifting, the filtering, the transformations, they are going to be the most likely things that get translated and pushed back, folded back to the data source. And in fact, what we can see in the query editor here in Visual Studio is that back here in the query editor, if I right click on the grouped rows step here and go to View Native Query, this is the SQL that's been generated behind the scenes. And when I execute the query to get the data, this is what's been generated for me. I can absolutely run my own SQL query through M as well. That's perfectly okay. But this is just proof that it is taking everything that I've done in this query and translating back to SQL. All right. Oh, why do I keep doing that? This leads us on to M. We have a new language to learn. The good news, or the bad news, is we've only got about 5 minutes in this presentation to learn it. Luckily, in 5 minutes, I will be able to teach you all you need to know about the M language. You'll be able to go away after this and put M on your CV, put it on LinkedIn, and get some amazing new jobs. Okay, now, I'm not going to do any more demos in Visual Studio because it's a little bit unstable. I'm going to do most of my subsequent demos in Power BI Desktop, which is the most reliable place to run M. Okay, now, here I am in Power BI Desktop. Here I am in the query editor. I've got some other queries to show you in a moment, but I'm going to click on New Source. I'm going to create a new blank query, and because I'm not in a VM or not in a desktop connection, I can use Zoom it. So this is what I'm going to use to create a new blank query. This doesn't actually create a new blank query. There's going to be some M code in here. I'm going to delete it, but we're going to learn some M. So let's click Connect here. At the moment the query returns nothing. I'm going to open the advanced editor, delete all of this stuff. Now, what is the first program we learn in any programming language? Hello World. Let's write Hello World in M. Okay, there's Hello World in M. That was difficult, wasn't it? So, every query that's generated in the query editor is a single M expression, and each M expression is evaluated to return a value. So this is a very simple expression. It's going to be evaluated, and when I click Done, it returns the text value Hello World. Now this doesn't look much like an expression, but we can edit this. Let's change this. Now what do you think this expression will return? 2. You were very hesitant. I thought everybody in Poland was super good at maths. There we go, it returns 2. It's not a trick question, I'm not going to try and embarrass you. Okay, so we've got expressions that are evaluated to return values. But I know what you're thinking. You saw that big chunk of M code that was generated by the query editor UI earlier, and you thought that was no way one big expression. Well, it was. It was a single expression. We can make expressions that look like that using something called a let expression. A let expression is a way of breaking up one big expression into multiple smaller steps. With a let expression, we have a let clause and an in clause. And in the let clause, we have a series of named variables, each of which has an expression associated with it. So I can go here and say step 1 equals 10, step 2 equals 3, step 3 equals step 1 times step 2 in, and then in the in clause I have the expression that the query returns, which can refer to any one of the variables. What do you think this is going to return? 30. Good. Click, run, and it returns 30. We're getting very close to the kind of things that we can do in the user interface. Something to point out, it doesn't seem that important, but it will help you interpret what's going on in the user interface, is that each of these variables, if the name contains a space, like this, we have to put the name in double quotes and put a hash in front of it to say that this is not a bit of text, it's a name. So this query will return exactly the same thing. All I've done is put a space in the name. Does the same thing. Each one of those named variables appears as a step in my list of applied steps. So you can imagine in the user interface, as we're connecting to a data source, we're applying lots and lots of changes, and each of these steps appears. Well, what's happening is that we are adding lots and lots of variables to this list of variables in the let expression that's being generated. One last thing to point out about this is that this looks like procedural code. It is not. All this is a list of variables, and these variables do not have to be in any order whatsoever. What's evaluated first in this expression is the in clause. The in clause here says, well, give me the value of step 3. Now, after that, the M engine has to evaluate the step 3 variable. To evaluate step 3, it has to evaluate step 1 and step 2. So it will go back and evaluate step 1 and step 2. If I change my query here just to return step 1, this would be evaluated, step 1 would be evaluated, step 2 and step 3 would not be evaluated at all. They're just variables. It can work out the dependency between the variables anyway. There are tons and tons of functions that we can use in M for doing data transformation. You can look those up yourself if you want. But we can now look at a query that's been generated by the user interface. This goes and gets the content of the dim date table in my local AdventureWorks database, and we can look at this and we can understand it. So we've got a let expression with 3 variables in it. In the in clause, we're returning the value of the variable dbo_dim date. That variable here is evaluated this expression, and that simply gets the dim date table, or the data from the dim date table, from this, which is the name of the AdventureWorks DW step, and the AdventureWorks DW step returns the database from the source step, and the source step just simply connects to my local SQL Server database. So, after this you might need to go away and learn some functions, but that's pretty much all you need to know about a let expression. One last thing actually to mention. I've got a query here that returns 30. Like I said, queries can reference other queries. So when we're writing some M, we can actually just use the name of a query as a variable inside another query. So if I go to create a new blank query here again, so I'm creating a second blank query. This one's called query 2. My original query that returns 30 is called query 1. I could say query 1 plus 100, and I'm able to reference the output of query 1 and add 100 to it, and I get, as you'd expect, 130. And that, apart from learning lots and lots and lots of functions, is all you need to know about the M language to be productive. And I think that really did take 5 minutes. Alright, so we know everything we need to know about the M language. Before we carry on and talk about all of the exciting things that are going to be possible with M, I have to state again that even though the engine integration is complete and it's present in Azure Analysis Services, the tools are not ready yet. They say they're ready, but actually they are not ready. SQL Server Data Tools 17, that's the version number, not the 2017 version of Visual Studio, is a bit unstable. And if you were in my session yesterday, you would have seen it collapse in a heap live on stage. And that was particularly awkward. But there are some key features that are missing. Now, there are things that we can do in Power BI Desktop and Power Query. For example, have queries that refer to other queries that refer to other queries. That is not yet possible inside SQL Server Data Tools. We can have queries that return functions as well. We'll talk about that in a minute. That's not possible yet in SQL Server Data Tools. And unfortunately, those are the really cool features that will allow us to do all of the new amazing stuff with Analysis Services. So it's awkward, but all of the rest of my demos I'm going to be doing in Power BI Desktop, but I will want you to believe and think that these are things that we can do in Visual Studio, and hopefully we will be able to do in maybe 1 or 2 months the next time we get a new release of Visual Studio. Something else to mention here as far as M language goes, some of you might have seen the news last week where it's now possible to create custom data connectors for Power BI. So instead of using the data sources that are available out of the box, you can build your own custom data connector and you'll be able to publish it and other people will be able to use it. So if you have your own particular software as a service thing, or you've got your own obscure database that you want people to be able to connect to, you can build your own custom data connector. You do that in M, and you can do that in M inside Visual Studio. The advanced editor I showed you just now in Power BI Desktop has no IntelliSense, no color coding, no auto indenting, no nothing. It is one big empty text box. So if you like developing in Notepad, you will like the M editor in Power BI Desktop. But that is slated to improve. We will get some good integration soon. And in fact here I've got the Power BI SDK installed on my local Visual Studio, and this is what an M query looks like in Visual Studio. It's still a little bit rough around the edges, which is putting it politely, but at least you can see here we've got IntelliSense, we've got color coding, This is, you know, the future of M. And it looks pretty good. Looks good to me. All right. The next thing to talk through for the rest of the session is, what is this going to mean for us? Because, you know, I know what you're like. You're professional BI people, and, you know, you looked at the user interface that I just showed you inside Visual Studio, the Power Query user interface, and you thought, well, you know, that's okay for, you know, kind of power users that use Power BI and Excel, but, you know, I'm not afraid of SQL. Why do I need to have some friendly user interface? Well, I think the Power BI user interface was something that was built into Visual Studio just because, yeah, it was expected to do that. The really interesting things that this is going to allow us to do come with the integration of M. And let's talk through what those things are. Probably the obvious first thing that this is going to allow is easy transition from models in Power BI to data models stored in Azure Analysis Services or Analysis Services on premises. So, as you probably know, the engine that powers the data model in Power BI is basically the same as the engine in Excel and the Excel data model, Power Pivot, and it's the same as the engine inside Analysis Services Tabular or Azure Analysis Services. It's the Vertipack engine. So if it's the same engine, it kind of makes sense that we would be able to take stuff that we developed in Excel and in Power BI Desktop and move it over to Analysis Services. And this is what this last change is going to allow. I think this was the main reason why Microsoft did it. The reason we haven't been able to do this so far is that, at least in Power BI, all data load is done using the M engine. So if you're going to take a model that's been developed in Power BI Desktop, you've got to be able to support M data loading inside Analysis Services to be able to export from Power BI Desktop to Analysis Services, whether it's on premises or in the cloud. Now, what this is going to allow you to do is to scale up your Power BI models. Because at the moment, if you've got a Power BI Pro subscription, the largest data model that you can possibly build is going to be 1 gigabyte of data. And if you've got a Pro subscription, you can only ever store 10 gigabytes of data inside Power BI. If you convert your model to Analysis Services database, you are limited only by the amount of data that you want to pay for in terms of hardware or capacity in Azure Analysis Services. So this is going to be one Power BI grow-up story. Of course, we now also have Power BI Premium, which is another way of scaling up Power BI. It's a very difficult question to know whether going to Azure Analysis Services or Analysis Services on-prem or going to Power BI Premium will be the right way for you to scale up your Power BI data model. Certainly Power BI Premium is pretty expensive. It starts out at $5,000 per month, and you've got to pay that for a year. So that's $60,000 a year just to get the entry level of Power BI Premium. Having Analysis Services, whether it's on premises or in the cloud, is as a place to store your data, is going to be a lot cheaper. So we've got the ability to move our Power BI data models now to Analysis Services. One thing that I think we're going to see as a result of this is a kind of blurring of the lines between corporate BI and self-service BI. Because in the old days, you know, self-service BI, even, you know, up until recently, self-service BI was people hacking around in Power BI Desktop, making something work, publishing it. It just worked. And then those of us who worked in the IT department, we did proper BI, we did corporate BI, and Analysis Services was our tool. What Microsoft wants to allow for is the situation where you start off in the world of self-service BI and maybe your data grows, maybe your skills improve, and then you're able to migrate seamlessly up to Analysis Services. Now this probably means we will start to see a lot more low quality models appearing in our analysis services instances, which may not be great, but it's a great message from Microsoft to promote. You know, seamless transition from Power BI to analysis services. A great, easy scale-up story that not many other vendors have. So there's that, and like I said, I think that's the main reason why Microsoft has made this change. But there are other things that are much less obvious. So, we like connecting to data. Analysis services could already connect to quite a lot of data sources, but the M engine today can connect to even more. I think at the last count there were at least built-in 80 possible data sources that you can choose from to connect from M. Now, some of these are not going to be massively interesting, but some of them are data sources that, yes, we will absolutely want to use as data sources for analysis services. For example, Cosmos DB, what used to be Document DB. All of these things like Azure Data Lake Analytics. M can already connect to them. Big data sources such as Spark. M can already connect to them. Online services like Google Analytics, we can connect to them in M. Web services in general needs a bit of programming work. You can't connect to them from the UI so easily, but you can connect to them in M. R scripts, if we're doing the R language and somebody's built a script for us perhaps to do some transformation or some prediction, that's all possible to use in M. And even though I know we probably shouldn't be doing it, we've actually now got very good, strong, reliable support for loading data from text files in M, much better than, for example, you would ever have in integration services. So basically, we are going to get access to a lot more data sources as a result of this. And of course, now, any investment that Microsoft makes for new data sources in Power BI will automatically appear not only in Excel, but in analysis services as well. So we're going to be able to connect to lots and lots more data sources. And like I said, as of last week, we've now got the Power BI custom data connector SDK available. We can write some M code and connect to any other data source that we want. Now, that's not going to be integrated into analysis services yet, but it will be at some point in the future. So you'll be able to write your own custom data sources and use them in analysis services as well. So we're going to have access to lots more data sources. What's more, and this is kind of going into even more technical detail, we're going to have a lot more data sources that are supported in direct query mode. So, direct query mode in Power BI and in analysis services is the mode where you can build a data model, you build a data set, but it doesn't contain any data. When your reports get data from the analysis services data model, analysis services in turn goes away and gets the data it needs from the data source by generating SQL. And at the moment, we can do that with data sources like SQL Server, APS, Oracle, Teradata. Now, the M language, if you're building a custom data connector, also allows you to build extensions that support direct query. And in fact, if you think about it, Power BI supports direct query on more data sources, for example Spark, than analysis services supports today. So with this, we are going to be able to do direct query on more data sources, even ones that we've not used or thought of already. So not only Spark, but SAP HANA, Impala, Snowflake, lots and lots of things. So I would imagine what's going to happen is we're going to end up in a situation where perhaps analysis services will be positioned as a kind of thin layer on top of that expensive big data project that you built because big data was cool, and then nobody actually thought how you were going to get the data out to the end users. With M-code, we are also going to be able to do some cool things with what are called modern data sources. Modern data sources is something that the analysis services team talk about. Really, they are just M queries used as data sources. But it's going to mean that we can do, some quite interesting, flexible things to break up the data load process and, turn it in and modularize it. Now, this is exactly the stuff that isn't implemented in Visual Studio yet. So let me go through this. But for example, here, what I've got in Power BI Desktop, what I showed you was a single query that connects to the dim date database and gets all the data. Now, there are 3 steps here: connecting to the database, connecting to the server, connecting to the AdventureWorks DW database, and connecting to the table. Now, that's one query. I can split this up into multiple queries because queries can refer to other queries. So for example, here is a query that just connects to my local SQL Server database. My local SQL Server instance. And then here I have a query that connects to the AdventureWorks DW database on that instance. And here I'm just referring to that previous query by name. And here I've got a third query that refers to the previous query and gets all of the data from the dim date table. So that original query that had 3 steps in it, now I've got 3 queries with 1 step in, or 1 expression in. And of course this means now I could have a query shared inside my analysis services project that connects to an instance. I could then have multiple queries that connect to different databases on that instance but still refer to that original instance. And then for those queries that connect to databases, I can have multiple queries that each connect to that database. So I'm not duplicating the server name or the database name in lots of different places. I can have shared queries that allow me to do that. And here, for example, is a query that goes away and gets the data from the dim product table from that database. And for example, here is another query that allows me to go away and run a SQL query against that database using the value.native query function. And that will just return a hard-coded filtered table. I'll be able to call stored procedures this way for the first time as well and use stored procedures as data sources. So that's all right, but maybe not all that exciting. But building on that, we're going to be able to use some more advanced M features for doing things that I think will be genuinely exciting. So we've seen we can have queries that build on other queries. What I think probably the most useful, the most practical application of this is where we want to have queries for partitions. So we have a big table and we want to partition it inside analysis services. Now today what we end up having to do is we create multiple partitions inside our table inside analysis services, and each partition is tied to a SQL query. And when the table changes or we want to alter and add a new column, we find that we end up having to go and edit all of those partitions and all of the SQL queries in all of those partitions, which can be really, really painful to do. But instead, now with shared expressions, basically queries that feed into other queries, we'll be able to do something like this. Here is a query called Fact Internet Sales. This query actually doesn't get loaded anywhere at all. It's simply a kind of staging query, but this query, if I ran it and loaded it into the data model, would load the entire AdventureWorks Internet Sales fact table from the AdventureWorks DW database. I can filter this table. So I've got an expression here that filters by order date key and only gives me the dates in the year 2001. This would be, a kind of pretty typical query. Now the interesting thing is here, I can take that query and I can turn it into a function. So a function is a data type in M. Queries can return functions. And with a function, well, it's what you'd expect. You pass a value to a function and we'll get a value back. It does something. So we've got a big query that returns the whole of our table. We know the M that can be used to filter that table for just the dates in a given year. We want to be able to build multiple partitions for all of the years that we've got data for. So what I'm going to be able to do here is to say, instead of hard coding the start date and the end dates like I did in the previous query, let's create a function where we pass the year in as a number, generate the start date because we've got meaningful keys here. Year times 10,000 plus 101 will give me the 1st of January on any year. Year times 10,000 plus 1231 will give me the 31st of January in every year. And it will return a filtered table for me. And now if you imagine that these are the queries that I'm using for each year partition, all I've got to do is call my get partition data query, my get partition data query that returns a function with the appropriate year. It will go away and filter the year. And because of query folding, it's going to generate some good SQL to be able to filter appropriately. So I think this is going to be the most useful practical example of this. But we'll also be able to do things like, for example, here I've got a query. And now something that I've got here is a feature again that isn't available in SSDT yet. It's called a parameter. So what we can create in M are special queries that just return a single value, and because they've got some metadata associated with them, the UI knows that these things are special queries called parameters, where we might want to be able to control the values that are passed in. So for example here on my source, I'm saying this is a parameter called source. It's going to be text, and here are the 3 possible values that I can use: dev, test and prod. Now all this is literally just something where I can choose to make this parameter return dev, test or prod. But now here inside this query, I've got a simple M expression that says, well, if source is dev, let's connect to this database. If source is test, let's connect to this database. If otherwise, connect to this database. So here, for example, we might want to switch between dev, test and prod, and do that for all of our queries. We can do this literally just by saying, well, let's go to test, and now all of my queries that refer to that parameter are just going to go to a different database. So it's going to be very easy for us as developers to be able to switch between data sources by setting up parameters and M queries that allow us to do that. Something else that you find yourself doing quite a lot, especially with Analysis Services Tabular, is that if you're working in SSDT, whether you've got a workspace database or you're using the new integrated workspace database mode in SSDT, when you're working in developing an Analysis Services Tabular database, you do not want to be loading the full data set from your source. Otherwise, when you go to the end of that data import wizard in Visual Studio, you end up importing the entire table, and it takes ages and your desktop crashes because you've got a gigantic fact table. Normally the way people handle that is by always building their Analysis Services Tabular databases through a series of views, and then on that view you will filter the table and you'll only get a subset of the data, and then when you deploy to production the views don't filter the data, or you can maybe run a script and change the view. We've got a new alternative here. Here is a parameter that I can just enter a number into. Now at the moment it's 10, and inside this query here I'm using the first n function to say, well, let's take the value of that number that I've passed in. If it's 0, return the entire table. Otherwise, let's just get the first n rows based on that number I've passed in. So with that parameter set to 10, I get the first 10 rows. If I set it to 100, I get the first 100 rows. If I set it to 0, I'll get absolutely everything. So it'll make it very easy for us to kind of control how much data that's brought in.
If you set it to nothing?
I would assume that I would write some code to stop people doing stupid things like that. But if I passed in a null, this would probably break.
So is there a try-catch expression allowed?
Yep, there's definitely try-catch expressions. Now, another thing that is kind of the opposite of what you might think about with this is, surely this is going to make everything slower. They're going through all of these extra levels, the data loading is going to be slower. Now apparently, I haven't tested this myself, but apparently the dev team say all of their testing, data loading performance is the same, except with SQL Server where they've managed to make it a bit faster. So actually as a result of going to these new data sources with M, we're actually going to have better performance loading data than we had before with the previous data sources, which I think is a really cool thing. Now, the last slide, the last thing to talk about is what should we not be using this for. You're going to be looking at all of this and you'll be thinking, wow, do I need to use integration services anymore? Do I need my data warehouse? Of course we still need proper ETL. Of course we need a data warehouse. Now, the kind of people who are perhaps growing up from Power BI Desktop will probably not have a proper data warehouse or know about proper ETL, but we know better. So this functionality is not going to be an excuse for you to start hacking away in M and doing all of those bad things. If you were an analysis services multi-dimensional developer, all of those bad things that people did in data source views, named queries and named calculations, that was bad back then. Using M functionality to do this in Tabular now is going to be equally bad. You should always take care to do proper ETL, build a data warehouse. Otherwise, you're going to end up with slow performance, logic buried away in M code that only you can read, and maintenance issues as well. So, whatever the cool things you can do with this, this is not an ETL replacement. Maybe one day we will get M integration into integration services. This is something that's been talked about, but I don't think anything has happened with it. When that happens, yes, we'll be able to use M for ETL, but right now this is not an ETL replacement. This is just something, like I said, for making partitioning easier, making managing your data sources easier, and maybe, connecting to lots and lots of different data sources. Right, that brings me to time. Thank you for listening. If you've got any questions, now's the time to ask them. All right, thank you for coming. I'll be around afterwards to answer questions if you want to talk offline. Thank you.